Okay, we're on 3.6, page 164. This is the last topic in this chapter, which means on Friday we'll go through the practice test, which means on Monday you'll take an exam over chapter 3.
Are we skipping 3.5?
We're skipping 3.5, right. We're skipping 3.5. We did enough of that, drawing those circles in that other chapter, so we'll skip that topic in this one. So, on page 164, the first thing you probably ought to put down is some notes. Excuse me, because the instructions say on page 164, in problems 1 through 16, symbolize each argument using the suggested abbreviations. In each case, determine the validity of the given argument. So how do you determine the validity of an argument? It's on page 156. First, you make a truth table. Okay. Second, now the book has you drawing a line through all the ones where the premises are not true, but I kind of prefer to focus on finding the ones where the premises are true. And I'll show you that as we work through it. So my second instruction said, circle the rows in which all of the premises are true. Then 3, for the argument to be valid, all of the conclusions must also be true. That is, all the conclusions where the premises were true. Put all in parentheses, because it's not all, it's all of the conclusions where the premises were true. Okay, you got that? So that's how we're going to work problems 1 through 16. And we're actually going to do that with problems 17 to 21 and probably do some of that with 22 to 27. So just put this in your notes and say this is the process for determining the validity of an argument. If you just read it and say, looks valid to me, or that doesn't look valid to me, you'll probably miss it. Because this is not how do you feel about it. This is what do the rules of logic. I started to say the laws of logic say. But it is kind of like in science. You have laws of this and laws of that. Well, it's kind of the laws of logic. So you just say, I have to have these laws down so I know how to enforce the law or how to work the problem. And one more piece of information that just might have stressed you out when you read it, but you might as well put it in your notes. If when I'm doing this chart, if there's no case where the premises are all true, the argument is valid. You go, what? Okay, remember back when we first studied if-then? And I said if-then is only false if the first premise is true and the second one is false. If the first one's false and the second one's true or false, I haven't lied to you. So that's what they mean by valid. If there's no case where the premises are all true, then there's no case where we could be lying to you. So even if you don't see the connection between the premises and the conclusion, if we're not lying, then it's a valid argument. even if it doesn't make sense. You go, wouldn't all valid arguments make sense? Not necessarily. Not in the way we make sense out of things. Okay, you got those down? Then let's go to work. Problem number 1. Going to help you with one of yours just to prime the pump, get this thing started. If you eat spinach, you can go out and play. So, you see what I wrote here? If you eat spinach, then you can go out and play. You put it in symbolic form. Now watch what's next for number 1. So that's the first premise. The second premise, you did not eat spinach. So premise 2 is not E. Everybody see that? See what we're doing? We're building this chart. And then therefore is the conclusion. And what's the therefore? You cannot go out and play. Not play. So I have 2 variables here, E and P. And what are my possibilities? True and true, true and false, false and true, false and false. You got that? Just like the and the or and the if then. This is how you work problem number 1. I'm actually working it for you. So just put this stuff on your paper and you'll have the first one done, and then you'll have a good model to follow for the rest of them. So now I've got my picture here. So I've done the first thing. Make a truth table. So I've done A. I've made a truth table. Now what did I say for the B to determine the validity of an argument? Circle the rows in which all of the premises are true. So let's see. See here, this is true and false. This is false and false. This is true and true. Aha. So what I do is I just circle them like this. Instead of circling the whole row, I just circle the premises that are true where they're both true. And then here's this one. True and true. Everybody follow what I'm doing? I'm looking at the premises to find the ones where they're both true. So I've done B. Circle the rows in which, and as I said before I got here, that in the book they draw a line through the ones that aren't true and true. And in my mind, I don't want to focus on what I'm not looking for. To focus on what I'm looking for, I just circle what I'm looking for and then ignore the rest of the stuff. So I've done B. I've circled the rows where all the premises are true. Now I'm ready for C, which says, for the argument to be valid, all of the conclusions must also be true, but not all of these conclusions, just the ones where the rows where the premises were true. So for this one, it's false. For this one, it's true. So one of them's true and one of them's false. So what does that make this argument? Invalid. You got that? No matter what you think about it, how you feel about it, according to the logical way of doing it, capital L logic, it's an invalid argument. Okay? Any questions? We ready for 2? Have you noticed the more of these we work, the more it starts to click in your head? So we'll just keep going here. And then after class, if you have some questions, stick around. I can answer them for a few minutes before I go to my next class. Problem 2. What does problem 2 say? If you eat your spinach, you can go out and play. So here's premise 1. If you eat your spinach, then you can go out and play. What's premise 2? You cannot go out and play. Second premise, you cannot go out and play. Not P. What's the third premise? Conclusion. There's the conclusion. What's the conclusion say? You did not eat your spinach. So not E. Now, I didn't talk about this up here, but let's talk about it down here. I was showing the process. Let's talk about it down here. So where am I getting my values that I'm putting under these columns? Does everyone know why if E then P is true, false, true, true? Do all of you know why that's the case? That's the rules for if then. Okay. If P is true, false, then what's not P? False, true, true. Everybody follow that? You look at you start out with your E and P, true, false, true, false. Every time. You put that in front of what you're working here. And then you go, okay. And if E is true, false, what's not E? False, true. Everybody follow that? We've been doing that the whole chapter, haven't we, almost? So we got that down. So I'm not going to talk about that as we work through these problems, because I'm showing you this validity thing. But if you don't understand how I got one of these columns of true and false, just raise your hand and ask a question and we'll stop and talk about it. Okay, so now I've made my chart. What do I do next? I circle, what did it say? Circle the rows where all the premises are true. Let's see, true and false, false and true, true and false. Ah, there's one, true and true. And then go over here and look at the conclusion, and what? The conclusion is true. So what does that make this argument? Valid. Everybody follow that?
I have a question.
Yes.
So what makes this argument valid compared to the one before?
Why is this one valid and the other one was invalid?
Yeah.
Okay, look at this one. We had true, false, and true. All have to be true for it to be valid. So I only look at the conclusions where the premises were true, but if they're not all true, it's invalid. Down here, I only had one, but one makes all this time. It's true, so that makes it valid. Good question. Okay, we ready for 4? Let's go to 4. What's 4 say? The Good Taste restaurant has good food. Well, where did I put that?
You're looking at problem number 5.
Oh, there's my problem. Thank you. Problem 4. I will learn this math or I will eat my hat. So there's I will learn math or eat my hat. That's the first premise. All right? Second premise, I will not eat my hat. Conclusion, I will learn this math. Now, let's fill in the columns. It's M and E, we have 2 variables, true, false, true, false, okay? That's this material right here. M or E, when is or true? If both are true, it's true. If one is true, it's true. If false and true is true, false and false is false. See where that column comes from? Your rules for or. If you don't have them in your head, then you say, okay, I have to look at my rules for or on my chart and fill this column in. Now, you could surely do this without looking at your chart, can't you? If E is true, false, then what would not E be? False, true. Everybody follow that? And if M is true, false, then M would still be true, false. So you see how we fill in the columns? Now what are we doing? We're up to step 3. So where were the premises? Here are my two premises. True and false. Nope, that doesn't work. Ah, here it is. True and true. True and false. Nope, and false and true. So I only have one premise where I want to look over here at the conclusion and say what? That conclusion's true. So what does that make this argument? Valid. You follow me? Good. Number 6.
So for the answer, all we're looking for is valid or invalid?
That's right. All we're doing is saying, is this argument valid or invalid? That's all we're looking for. And we're doing all this work here. We're building all this chart to determine that. Number 6. Whoa, what happened here? Well, if prices go up, management will scream. If, premise 1, if prices go up, then management will scream. If prices up, management screams. What's the next premise for 6? If management screams, supervisors get tough. If management screams, supervisors get tough. That's the second premise. What's the conclusion? If prices go up, then, what's it say? Where'd it go? If prices go up, supervisors will get tough. So I have 3 variables, U, S, and T, which means when I make my chart, it's going to be like that one that you have with 3 variables. Okay? So now I have to fill in a column for each one of these. Each one of these if-thens. Now, if you don't remember it, get out your if-then chart to check when is if-then true and when is if-then false. If-then is always true unless the first one's true and the second one's false. So for U and S, true and true is true, true and true is true, true and false is false. Everybody see that? See how you just run down through there and check them out? So you have to have somewhere on paper in front of you your rules for how do you determine when if-then is true. Then you do the same thing for S and T. First we did U and S, then we do S and T, and then we do U and T. So we have 3 of these if-then things that we have to fill in the table for. So now that we've done all that work, now we're ready for step 2. See, this is all just step 1 in the process. Step 2 says, circle the ones where the premises are true. Well, there's true and true. True and false, false and true, false and true. Here's true and true. True and false, true and true, true and true. So you see how I've circled the ones where both premises are true? Now I come over here and say, so what about true and true? That's true. Good. True and true, that's true. All right, true and true, that's true. True and true, that's true. So, if all of these are true, then what does that make this argument? Valid. If one of these would have been false, we would have said what? Invalid. Everybody follow that? It's going to take a little time to make all these charts, isn't it? And you probably won't have as much fun doing it as I did. And I'm sorry for that. But doing this over and over and over again really does kind of ingrain in your mind these principles of logic. So it's worth doing the homework. That's why I give credit for it, because it really does help fix in your, even if you don't remember it, you've kind of fixed it there. And when you see it again, it'll come back to you. Number 8. Okay, what do we have here? Babies are illogical. So there's my first premise. Premise 1. Nobody is despised who can manage a crocodile. Now, I don't know if you can see this, but does nobody is despised who can manage a crocodile? Can you see that? Can you see the if-then statement here? If you can manage a crocodile, then you are not despised. Do you see that if-then? If you can manage a crocodile, then you are not despised. And that's the second premise. I wasn't sure when I was working through these if all of you would just be able to, you say, you know, one of the toughest parts about setting this stuff up is actually building this chart, because you look at these words and how do I go from these words to these symbols? And if you're struggling with that a little bit, I found something on the internet that I uploaded to Canvas under our math class on Pages, and I think I labeled it Logic Rules for 3.6. And it's got a big chart that shows all these various constructions and what they mean. So I thought that's a helpful chart. So I put it up there. So if you look at it and it helps, okay. If it doesn't, just keep working through it till it makes sense to you. And keep coming in here. If you're working on this homework and having trouble, you can come in here early on Friday and I'll help you figure it out. Because a lot of it is just you have to do it often enough to make it kind of stick in your head. And then even once you have it stuck in your head, you have to keep looking at the rules to make sure you're following all the rules for logic. Okay, so that's the second premise. Then there's a third premise. Illogical people or persons are despised. So if you're illogical, then you're despised. You follow what we're saying? I mean, you don't have to agree with it. They're just saying that we're just taking the things that they give us, the premises they give us. And then when it says hence, that's my conclusion. Hence, babies cannot manage crocodiles. So if you're a baby, then you cannot manage a crocodile. So do you understand how we went from these words to this symbolic language here on this paper? Premise 1, if B, then I. Premise 2, if M, then not D. Premise 3, if I, then D. And conclusion, if B, then not M. Using the letters that they gave us. Okay? So now what do we have here? We have B, I, M, and D. So we make a chart for 4 of them. My goodness. Wait a minute. Maybe there's another way to look at this. Let's take, here's if BMI, and then over here, I don't know if this will help or not if I'm going to mess this up drawing all these pictures. Here's if I, then D. So I take this one and stick it down here. Okay? You go, why? If B, then I, and if I, then D, then what can I say from that? Then I can say if B, then D. You follow that progression? Does everyone see that progression? If B, then I, and if I, then D, then I can say if B, then D. Because this I is the same here. Everybody see that? So now I have if B, then D. And look what this says. Look at this one. If B, oh, wait a minute. Okay, here's this one. I'll change to blue. So here's this one. The contrapositive of if M then not D is if D then not M. Remember that contrapositive we studied last time on Monday? And so now watch what I have. Now I have if B then D, and now I have if D then not M. So what can I say from that? If I have, change to green here. If I have if B then D, and I have if D then not M, then I can say if B then not M, which happens to be the conclusion. Do you follow my chain of thought? What did I do here that's bothering you? Using that contrapositive? Because see what I'm doing is, can you see my strategy is, I'm looking, I'll use contrapositives quite a bit here because I'm looking for ways to create these, can I call them little chains of logic? It says if A then B, and if B then C, and if C then D, then I can say if A then D. You follow the rationale? Well, if so consequently, this is valid. This is a valid argument. Now, if you didn't like what I just did, using this little chain of thinking, then you just go over here and make a chart for each one of them using all of this stuff. And I didn't even want to take time to do that. But you can do it if you want to. All right, so now let's do number 10. Bill did not go to class this morning because he wore a red shirt, and he never wears a red shirt to class. So look at this for a minute. He wore a red shirt. There's premise 1. R. What's premise 2? He never wears a red shirt to class. That's premise 2. If he's wearing a red shirt, then he doesn't go to class. And what's my conclusion? The thing that they put at the front of the sentence. He did not go to class. You see how part of this, you say, you know what? I understand the process of building a chart and then circling the things, the premises that are true, and then finding out if all of the conclusions are true. And if they are, then it's a valid argument. What I'm going to have trouble with is setting up the chart. And that just takes talking through it and practicing it. So that's why we're working through it in class and trying to do enough of these to help you kind of see the process. But do you notice we're going to be looking for a lot of if-then phrases? So just keep that in mind, because problem 10 is a little tricky. I mean, once we have it set up, we go, okay, premise 1 is R. That's true, true, false, false, just like R over here. If R, then not G. If G is true, false, then not G is false, true. R is just true, true, false, false. So if then is false, true, true, false. True and false is false. True and true is true. False and false is true. False and true is true. For if then. Agreed? Go, I don't know. Well, get your chart out and look at it, and it'll tell you that's true. And then if G is true, false, not G is false, true. So now that I've got it set up, I come over here and say, okay, I'm looking for this and this. No, here's one. This and this. Premise 1 and premise 2 are both true. False and true. No, false and true. No. So I only have one. So I look at this one, come over here and say, this is true. So that makes the argument valid. Okay? Number 12. If you are enrolled or have been accepted half-time at college, you can apply for a loan. If you're enrolled or, what did it say? Accepted half-time at a college, if then you can apply for a loan. So this is my first premise. And then what's my second premise? You have not been accepted half-time. Not H. That's my second premise. What's my conclusion? Hence, you cannot apply for a loan. Not A. That's my conclusion. Now I have 3 variables, so my chart has 8 possibilities in it. Now, does everyone understand? How do you determine or? We're looking at E and H. And or is if either one's true, or is true, right? So I filled in this column based on comparing these two. Then I just copied A, and then I come here and look in the middle for if then. When is if then true? Well, when is if then false? If the first one's true and the second one's false, it's false. There's another one. There's another one. And all the other times it's true. You follow the thinking? If not, get your chart out and look at it and just say, these are the rules of logic. So now my second premise is not H. So if this is H, not H would be true, true, false, false, true, true, false, 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 true, true, false, false, true, true. And then if my conclusion is not A, and this is A, then not A would be just the opposite. True, false, true, false, true, false, true, false, false, true, false, true, false, true, false, true. So now I'm back looking at my 2 premises, and I'm looking for true and true. Nope, false and false. Here's one, true and true. Here's here's another one, true and true. And here's another one, true and true. So I come over here and look at this one, and this one, and this one. And what do I conclude? Valid or invalid?
Invalid.
Invalid. Everybody follow that? For number 12? And why is it invalid? Because for 2 of these, where they were both premises were true, it was false. It has to be true all 3 times for it to be a valid argument. Number 14. We will pay for collision loss only if. Do you have your chart about only if? Only if is we will pay, if we pay, then. collision coverage is afforded. Looking for their letters there. That's the first premise. If we pay, then collision coverage is afforded. Look at your only if chart. Second premise, collision coverage is not afforded. So that's not A. Conclusion, hence, we will not pay for collision loss. Conclusion, not pay. So I make my P and A, true and true, true and false, false and true, false and false. So what about if P then A? True. True false is false. False true is true. False false is true. If A is true false true false, not A is false true false true. If P is true true false false, not P is false false true true. So now I take my premises and start looking for true and true. Here it is, right here. This one's true and false, false and true, true and false. So I only have one where they're both true, and it happens that the conclusion is true. So what do I say about this argument? It's valid. Everybody follow that? Good. Let's do another one. This is fun. Number 16. Additional sheets of paper are attached unless more space is needed. I don't think the textbook told you this. Another logic rule. Unless means if not. Unless means if not. If no more space is needed, not M, then additional sheets of paper are not attached, not A. And the contrapositive of that is if A, then M. I'm just taking the stuff and you say, why are you using the contrapositive? Because it'll be easier to look at the value, the truth table for the contrapositive than for the statement itself. So I come over here and put if A, then M is my first premise. All built on this word unless. Now, see, watch what I just said. Look at the words there. Additional sheets of paper are not attached unless more space is needed. So, if additional pages are attached, then more space was needed. You kind of follow that from that, looking at that statement? So that's my first premise. What's the second premise? More space is needed. What's the conclusion? Additional sheets of paper are attached. So let's check it out. Here's true and true. Here's true and true. Everything else doesn't match out. So we say, okay, look at this one, look at this one. This one's true and this one's false. So what does that make this argument? Invalid. You see why? Because they both have to be true. Both of the conclusions would have to be true for it to be valid. Number 18. Number 18 shows a picture. If P then Q, so I put it here, that's the first premise. And the second premise is P. And the conclusion is always under the line. That's those three little dots. Therefore, the conclusion is Q. You follow that symbolic language there? Now they haven't given you words that you have to make symbols for. They're just giving you the symbols and say, check out the validity. Determine whether each argument in problem 17-21 is valid. So to do that, I make a chart. P and Q, and then an if then, I make my column, P column, Q column, then I say, okay, here are my two premises, true and true, false and true, true and false, that's it. So there's only one where both premises are true and the conclusion is true, so that makes it valid. Number 20. What does 20 say? If P then Q, that's my first premise. Not Q, that's my second premise. Conclusion, not P. Everybody follow how I'm making my chart here from that problem 20 in the book? Then I fill in the chart. I make the table. So now that I've got the table made, I go, okay, I'm looking for true and true. No, 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 here's one. True and true. And what about the conclusion? It's true. So that makes this argument valid. With me? You can't do this without building these charts. So when you turn in this homework, if you don't have charts on it, the only way you got the answer without the chart is looking in the back of the book. That won't work. I have to see those charts. Number 22. By the way, I should mention something here. I was just reading my student evaluations of instruction from last semester, and somebody said he doesn't grade our papers and give them back to us. So does everyone understand you're supposed to grade your own papers by looking in the back of the book? Apparently somebody missed that last semester, and I didn't point that out to them in class. But you grade your papers to see if you got it right, and then you check the ones wrong you missed, and it doesn't change your grade. You look at the ones you missed. If you don't know why you missed one, write me a note and I can send you an email or give you your paper back or something to help you understand it. But if you understand why you missed it, then you just say, I understand, and you go on your way. And I give you full credit for the homework, for doing the work, which is you do the work, you grade your paper, you look to see why you missed it and figure it out. And if you're having trouble with something, that's why I come 30 minutes before class starts to help you with it. Okay, let's move on to number 22. If P, then Q. If Q, then R. If R, then not S. And conclusion is if, then they want us to come up with a conclusion. So this is blank. So let's take it off of there. So then what are we going to do? Watch. If P, then Q. And if Q, then R, see that? Then that would result in if P, then R. Do you follow that? That chain thinking? Now, but look at this. Here's if P, then R. So I've got if P, then Q, if Q, then R. So that would be if P, then R. Then I have if R, then this. So I can put if R, then not S over here. So I end up saying what? If P, then not S. Is that what I had written down there? For number 22, if P, then not S. Everybody see that progression? If not, you could make a little table like we just did for the other problems and come up with the answer. No, you couldn't, because they don't give the answer. So you have to think through this process. So now they're going to force you to do some of this stuff. Number 24. If P then Q, okay, maybe change the red here. If P then Q, and then let's take this one, because see, here's a Q. If Q then U, so I put this over here. If Q then U, so if P then Q and if Q then U, then what do I have next? That results in what? If P then U. Everybody see that? If S then not R is contrapositive, if R then not S, you go, why did you do that? Because, oh, I didn't do that one first. I came down here and said, if not U or T, that's equivalent to if U then T, because of what I have up here. If P then U. So I'm looking for an if U then something. I'm trying to find a U to put in front, so to speak. So this becomes if U then T. So now we have, and since this says if T then R, if T then R, then I have if U then R, and here's, move it up a little bit, if R then not S, and if P then U, if U then R, so I can come over here and say if P then not S. Remember from page 132? Not P or Q is equivalent to if P then Q. You probably need to keep those little rules someplace where you can look at them when you're working through these to see how you're going to use them to rearrange these premises to come up with to rearrange the premises so you can build this chain of logic. What was that, 24? Let's do 26. If P then not Q, if R then Q and R. So let's erase this, because that's not in there. Is it? No. So, here's if P then not Q. So I look at this and I'm going, hey, guess what? This is equivalent to if not Q, then not R. So now I have not Q and not Q. So what can I say next? Then I can say if P, then not R. Which is equivalent to saying if R, then not P. And since I have R here, what do I put down here underneath? Not P. You follow that? (28) No people who assign work are lovable. All supervisors assign work. So what's my conclusion? If all supervisors assign work, and people who assign work are not lovable, or no people who assign work are lovable, then no supervisors are lovable. Do you follow that thinking? Have we done enough logic where you can start to think through some problems now? Let's try number 30. No employee who doesn't arrive for work on time will be promoted. So no employee who doesn't arrive for work on time will be promoted. So here's no employee, and then some employees do not arrive for work on time. See that? So what do I say about some of these employees? Some of these employees will not be, how come I didn't write promoted up there? I don't know. Will not be promoted. Maybe that's what I had there and it erased it on me. Who knows what's going on? Sometimes this little tablet has a mind of its own. That's my conclusion. And that's what they want you to do, is find a valid conclusion. Number 32. If it rains, then the grass will grow. If R, then G. And notice what it says next. G is a sufficient condition for cutting the grass. So do you have your table with a sufficient condition? That's equivalent to if G, then C. So watch what I have here. Oh wait, not finished yet. What's the next premise they gave us on 32? The grass is cut only if it's higher than 6 inches. The grass is cut only if it's higher than 8 inches. So if C, then the grass is higher than 8 inches. Now do you have this? Now do you see this? If R, then G. Well, let me change this to black. I think it's sometimes easier to see. No, doesn't want to change. Okay. If R, then G. If G, then C. If C, then what is that? H8, the height is 8 inches. So the only conclusion I can draw from this information is, if it rains, then the grass is 8 inches tall. By using all of that information. If it rains, the grass is higher than 8 inches. Which sounds a little stupid to me, but you know, I'm just following the rules of logic and filling in the chart. Number 34. All ducks can fly. If it's a duck, it can fly. Whoops. Well, come on. There. If it's a duck, it can fly. No land birds eat shrimp. If it's a land bird, it doesn't eat shrimp. Only flightless birds do not eat shrimp. If it doesn't eat shrimp, then it's a flightless bird. Did they say something else here? Oh, see this out here? LB, if LB, then not S. And if not S, then not F. So I can say land birds. If it's a land bird, then it doesn't fly. Is that what F stands for? Yeah, it doesn't fly. And then the contrapositive of that would be, if it flies, then it's not a land bird. Why did I want the contrapositive? See this? Isn't this fun? If D then F, and if F then not LB, then I can conclude by saying if it's a duck, then it's not a land bird. Or the other way to say it is no land bird is a duck. I prefer to say if it's a duck, it's not a land bird. Number, by their definition of a land bird. 36. No music student who doesn't practice will learn to play. So none who do not practice will learn to play, which is equivalent to all who do not practice will not learn to play well. Some do not practice, so some will not learn to play well. Let's do one more. 38. No student who works late can be a party animal. All supervisors, and it's understood, even though they didn't say that, all student supervisors work late. So there's that work late and work late. And students who work late cannot be party animals. So no supervisor can be a party animal. And that's your conclusion. I guess that's probably enough. It looks like. So stop. Boy, there's some fun ones here, but stop at what? Did I work 38? So how about stop at 37? That'd be good enough for you. We've done enough of this stuff to give you a headache. If you have any questions, stick around and I'll try to help you. Be sure to sign one of those attendance forms sitting on those tables.